Good morning. So we continue the lesson. So there is one very small page in the book left, so I want to talk about that, and then we just go to the new lesson. Okay. Uh, so let me give you some titles. The first thing that I want to talk is trigonometry of opposite angles. Of course, for these first part of the lesson, there is nothing new. I want to review and draw to your attention to some particular useful properties. So you should have it in the back of your head sometimes when you want to use it. Okay, so what do I mean by this first? So this means if you have an angle theta, and then you multiply it by a negative sign, it becomes the opposite angle. And then you ask how sine of this negative angle is related to the sine of the angle itself. Is there any relation in general that we can discover? So this is what we want to answer, okay? So if I give you an angle, you multiply it by a negative sign to find the opposite angle. The question is there any relation between the sine, cosine, and tangent of this negative angle with sine, cosine, and tangent of the angle itself? We want to discover that, and there is a very nice relation, and I really want you to have it in your memory. Of course, you can always find them by visualizing the unit circle as I want to teach you here, but it is more efficient if you know about these rules by heart. So can you answer this question? How we can answer this question? So I would say to myself that, okay, let us go to the unit circle. Let us assume that theta is this angle, for example. And then the final point of this has two coordinates, one x coordinate, one y coordinate. The x coordinate is, of course, cosine of this angle, and the y coordinate is sine of this angle. But now if I ask you where is minus theta, so then where is minus theta? So minus theta is this angle. Yes, this is minus theta. And then if I ask you where is this point, by symmetry you realize that this is exactly the mirror image of this black dot with respect to the x-axis. So if I ask you, can you read the coordinates of this red dot based on the coordinates that you see here, you immediately realize that the x coordinates are exactly the same. So if this is x as well. But if this is y, because it is flipped over the x-axis, this becomes minus y. Yes? Okay, and then if I ask you what is sine of theta, what is sine of theta? You would say sine of theta is this y coordinate. If I ask you what is sine of minus theta, you would tell me this is the y coordinate of this red point, which is minus y. And then you immediately realize these two numbers, whatever they are opposite, because one of them is equal to y itself, the other one is negative of y. So we discovered the relation actually. So whenever you have sine of a negative angle, if you want to, you can move this sign, you can flip it over this sign and write it here. Yes? But what can happen for cosine? It's still on it's on the board, yes? What is cosine? You see that cosine is the x coordinate, and the cosine is also the x coordinate. So theta and minus theta have the same x coordinates, yes? So then it means that cosine of minus theta is exactly equal to cosine theta. Yes? So remember, if you have a negative sign inside the sign, this negative sign can be pulled out. But if you have a negative sign inside cosine, you can just simply drop the negative sign. You can just simply ignore that. This is the rule of thumb, but if you want to understand it, you have to visualize it here. Everyone understand what's going on? Okay. And then what happens for tangent? I divide this by that, it becomes tangent of minus theta. I divide this by that. Negative, positive, when I divide it becomes negative. But when I divide sine by cosine, it becomes tangent again. So you see that for tangent, minus sign is also pulled out. So that is something I want you to know. For example, if you want to calculate sine of minus pi over 6, okay, so you see there is a minus sign, you remember this rule, so you pull this minus sign out, because minus pi over 6 is not one of the angles that you see in the table. But they can ask you for the exact value of this without the calculator. So the first thing that you need to understand is that this minus sign can be pulled out, yes? And then you need to understand how many degrees is this one. So the rule of thumb is that pi is equivalent to 180 degrees, and then you divide it by 6, it becomes 30 degrees. And then you go to the table, find 30 degrees and read it. If you do that, it becomes 1/2. But there is a minus sign here, so it becomes minus 1/2. So these kinds of questions, you should be very good in answering them. Yes? Any questions? So if I want to write a remark here, so what can I write? I can say that if alpha and beta are angles, so what is the relation between sine of alpha minus beta and the sine of beta minus alpha? How they are related? I hope that you can see that this angle, whatever it is, and this angle, they are opposite. Why they are opposite? What do I mean by opposite numbers or angles? It means that when I add them, the answer is 0. Minus theta is opposite of theta. Why? Because if I add these two, it becomes 0. So alpha minus beta and beta minus alpha are also opposite angles. Why? Because if I add them, beta and beta are cancelled, alpha and alpha are cancelled. So this means that is 0. So according to this rule, I am facing the sine of two opposite angles. And then I realize that one of them is the negative of the other one. So if you have this situation, if you interchange these two with a minus sign, then you have to put a minus sign here. Yes? But of course, what happens here? What is the relation between these two? Yes? What is that? Yeah? They are the same, yes. Why do you doubt about it? Alpha plus beta is the same as beta plus alpha. If they are the same angles, so the signs are also equal because they are same angles. But alpha minus beta and beta minus alpha are not the same angles. What is the relation between them? They are opposite to each other. Why? Because if I add them, it becomes 0. So this actually follows this rule again. Okay, what happens if I have cosine alpha minus beta and cosine beta minus alpha? Are these angles the same? No. Alpha minus beta and beta minus alpha are actually opposite. But for this case, for cosine, I don't care. Yes? So they are equal. But for tangent, it's also opposite. Okay, so I really want you to have this in your memory somehow. Only minus sign, by the way. Don't push this analogy further. For example, so you can say that sine of minus theta can be viewed as sine of minus 1 theta. And then what I am saying is that minus 1 goes out. Yes, and you can write minus sine theta. But that is completely exceptional. That is only for minus 1. If I have sine, for example, 2, I have seen some students pull this 2 out and write 2 sine theta. That is completely wrong. But this is also part of our lesson. We will probably reach to that part later or next session. But I just want you to understand, don't push this analogy further. That is only working for minus 1, not any other number. Yes. In the case of cosine, you just drop the minus sign, minus 1. Okay, let me change the topic now. So trigonometry of supplementary angles. This also happens quite a lot in trigonometry, so it's good to know at least. I don't expect you to memorize that, but you should be quick in visualizing the correct picture in your head to be able to deduce what we are going to find. Okay. So what do I mean? What do I mean by supplementary angles? For example, 150 degrees and 30 degrees are supposed to be supplementary because the sum of them is 180 degrees. And then this is the terminology I use. I would say that 150 is supplement to 30 and 30 is supplement to 150. So that's the meaning of supplementary angles. If I ask you what is the supplement of 190 degrees, what is the supplement of 190 degrees? Yes? Minus 10 degrees. So that's also possible in trigonometry, yes? So this is also a pair of supplementary angles. Now, if I give you theta in general, so if I give you 150 and I ask you for supplement, you immediately answer 30. If I give you 190 and I ask for the supplement, you give me minus 10. So if I give you theta and I ask you what is the supplement, what is your answer? Yes? Minus theta. So this is what we want to understand now. We want to understand how sine, cosine, and tangent of these two angles are related. So in other language, I want to ask myself, is there any relation between sine of the supplement angle and the sine of the angle itself? I want to discover if there is any relation between them in general, not coincidentally, for all choices of theta. So by the way, this is all for all choices of theta. So then again, if you want to discover it, you need to visualize it through the unit circle. And I think we already did that. The only reason that I am talking about this again, because I want to cover that page in the book, and then we want to have them in some place gathered together systematically. So can you describe what is happening now? For example, if this is my angle theta, of course I have to convince myself it is independent of the location of theta, but let us assume that this is the case. Where is 180 minus theta? So this means that if I start from here and go half a circle, it becomes 180, but I have to stop before that. How much before that? Theta degrees before that. So then it means that I have to separate theta degrees from here, but this angle becomes 180 minus theta, yes? So then from size point of view, this angle is also theta. Now, if I give you the points, the coordinates of this point, if I draw a good picture, hopefully you can realize that this point here is nothing except the mirror image of this point, but with respect to the y-axis. Okay, so if I ask you, can you read the coordinates of this point, you will see that the y-coordinate is the same, exactly. The x-coordinate and the x-coordinate here, from size point of view, they are the same, but one of them is in the positive one direction, the other one is a negative. So in that case, I have to write minus y, minus x. Yes? And now I ask you, what is the relation between these two? Sine of theta is this y-coordinate. Sine of 180 minus theta is this y-coordinate. They are exactly the same. So this means that they are exactly equal. Yes? And then what is your guess for cosine of 180 degrees minus theta? What is this one? The cosine relates itself to the x-coordinate. So the x-coordinates are not exactly the same, they are opposite. So it is minus cosine theta. And of course, you don't need the unit circle anymore to answer the question related to the tangent, because for finding the tangent, I just divide sine by cosine, it becomes tangent. When I start dividing here, it becomes sine over cosine, which becomes tangent again. But of course, this is positive, this is negative. The answer will be negative. So this is what we title under this topic. So supplementary angles. So you know that the sines are exactly the same. Cosines and tangents are opposite. Yes? For example, let me ask you to calculate the exact or determine the exact value of, let me write cosine of minus 5 pi over 6. So assume that that table is given to you and you're supposed the table of famous angles are given, and then you're supposed to determine the exact value of this. So if I want to calculate this myself, first I will not use that rule, I will use this rule, yes? Because I have a negative sign in front of cosine. So what can I do? According to what I told you here, it becomes exactly equal to cosine 5 pi over 6. Why? Because of this equality. Okay, and then 5 pi over 6 is supplement to a famous angle. What is that supplement? So I'm asking, can you give me the supplement of 5 pi over 6? 5 pi over 6, the supplement of this is an angle, so that when you add these two, it becomes 180 degrees, which in the radian mode, it becomes pi. So what is the question mark? Yes, pi over 6. Yes. So this becomes equal to cosine pi minus pi over 6. Do you agree? Because there is no difference between pi minus pi over 6 and 5 pi over 6. Yeah, of course, if you answered that question, you can immediately answer it. Yeah, so you can say that because this is at 180 minus 30, you see cosine of 180 minus an angle is minus cosine of that angle. So that is cosine of pi minus pi over 6. So this becomes minus cosine of that angle. Yes? And cosine of pi over 6, you can see it in the table. It is a square root of 3 over 2. There is a negative sign there, so it becomes this. Yes? So for example, if I ask you what is tangent of 210, okay, you don't really need to write so much, but let us do this one faster. If I ask you what is tangent of 210, can you visualize a famous angle which is supplement to 210? What is the supplement of 210? What is that? What is the supplement to 210? Minus 30, yes? So it is minus 30. So minus 30 is supplement to 210. How the tangents of supplementary angles connected? One of them is negative of the other one. So if you want to write that, you need to write minus tangent of its supplement. But what is the supplement of 210? You just mentioned that. It is minus 30 degrees. Okay, let me just explain this once more. So here you know that if I have two supplementary angles, tangents are opposite. Yes? On the other hand, You know that 210 and minus 30 are supplementary. Why? Because if I add them, it becomes 180 degrees. According to this rule, the tangent of these two angles are opposite. It means that the tangent of 210 and the tangent of 30 minus 30 are opposite. So they are not equal, they are opposite. Yes? That's the meaning. But now what can I do? I realize this rule. Minus inside tangent can go out. Yes? So that minus sign will go out and will cancel that minus sign. So let me write it in two steps. And then it becomes tangent of 30 degrees. And this is one of the famous angles. You can find it in the table. So if you go and the answer is 1 over a square root of 3. You can read it from the table at the very end. Do you remember we had this before? This is not a new lesson at all. Yes? So even if you don't know anything about these things, you just draw the unit circle and try to convince yourself that this is the case from the unit circle. That's the reason that I told you. This is not a new lesson at all. But the reason that I want to talk about this, because there is a half a page in the book with some exercises there. So I want to put them in one place that you can see them. And the other one is the trigonometry of complementary angles. I think this is very famous because I emphasized a lot on that when I was teaching. So can you tell me in advance what we will discover? Yes? What we are supposed to discover? The same question for complementary angles. What do I mean by complementary angles? I mean the angles whose sum is 90 degrees. So what was the important rule I emphasized a lot in this course for that rule? Thank you very much. You don't remember? So this time I will not emphasize. Probably you will remember better, yes? If you have two complementary angles, sine of one of those angles is equal to cosine of the other one. That's a very famous statement. Okay, so let me just write it. So that's good that we are bringing it up again because that's important. So trigonometry of complementary angles. Okay, so this you already told me. So but by the way, when I say complementary, for example, what is the complement to 75 degrees? The complement to 75 degrees is 15 degrees. What is the complement to 100 degrees? Minus 10 degrees, yes? And in general, if I ask you what is the complement to theta, what is the answer? It is 90 degrees minus theta. So these are the generic complementary angles. If one of them is theta, the other one is 90 degrees minus theta, yes? So we want to discover what is the relation. So what can I write for sine of 90 degrees minus theta? And what can I write for cosine of 90 degrees minus theta? So how should I answer this? Again, I have to do it using the unit circle, okay? So I have to be a little bit careful in drawing the pictures so to give you the right impression that what I'm trying to do is correct. So assume that this is theta. Yes, assume that this angle here is theta. And I want to know where 90 minus theta is. 90, if I start from here and go up to there, of course I have rotated 90 degrees, but I want to rotate a little bit less. How much less theta degrees? Yes. So this means that I separate theta degrees from this direction as well. From size point of view, I will consider this theta, but if I ask you what this angle is, you would say it is 90 degrees minus theta. So if I ask you where is the final point for theta, you will show me this blue point. And if I ask you where is the final point for 90 minus theta, you will show me this red dot. Now the same question. Assume that I give you x and y coordinates here. My question is that what are x and y coordinates of the red dot? Yes? Y and x. Yes. So why is that? It is not as obvious as before, so you have to do a little bit of good reasoning for that. So if you do this precisely, hopefully you will see the symmetry going on. So if I draw this line here, and I draw this horizontal line here, vertical line here, horizontal line here. Hopefully you realize that this triangle is congruent to this triangle. Yes? So this means that this length, whatever it is equal to this length. So, but you know what this length is. This length is the x-coordinate of your blue point, so this is x. So this is x, this also becomes x. So from here to here is x. Whatever this number is, this will play the role of the y-coordinate of the red dot, yes? So this means that this I will take it and put it as the y-coordinate. Do you see? Because it is on the y-axis. And the same thing here. This small length that you see here will be equal to this small length here. But if I ask you what is this small length, you would say this is the y-coordinate of this. So from here to here is y. So then it means that from here to here is also y. But what is y for this point? Y is the x-coordinate of this point. So I will put y instead of x. I will put it in the first component. So hopefully you are convinced that if the coordinates of this blue point is x and y, the coordinates of the red point is flipped, is y and x. So then what does it mean? So if I ask you what is sine of 90 degrees minus theta, you will say that this is the y coordinate of the red dot. The y coordinate of the red dot is x. Yes? But if I ask you what is x on the other hand, you would say that x is the x coordinate of the blue point, so it is the cosine of theta. So you see that sine of 90 minus theta is not related to sine theta, it is related to cosine theta. And this was for your understanding. I just clean it and write the formula. But why the formula is correct, that was the reason behind that. So this means that sine of 90 minus theta is cosine of theta. And what is cosine of 90 minus theta? Cosine is the x-coordinate, which is y. But y is this one, which is sine of theta. So that also becomes sine theta. Okay, and then if I want to answer the same question for tangent, I divide this by that. I don't know, this is considered to a level 3 problem in your book, but that's very simple. You just divide this by that, it becomes tangent. Of course, if you divide this by that, it is not tangent anymore, because this is cosine divided by sine. There is another name for this in trigonometry, but that is missing from your book, or education, I don't know, curriculum. That's called cotangent. So cosine over sine has another name because that's also appearing a lot. It is cotangent, okay? But in the book, you can write it in that way. So what is the relation between cotangent and tangent? One of them is the reciprocal of the other one. You have flipped the numerator and the denominator, yes? So this means that this is exactly 1 over tangent of theta. The reason that you write in your book, you see it like this, because if you go to university books, you will see cotangent in front of this. But the reason that they have written it in this way, because they are not talking about cotangent. So this means that the product of the tangents of complementary angles is equal to 1. So this means that if you have two complementary angles, sine of one of them is equal to the cosine of the other one and vice versa, but the tangents are reciprocal. Yes? And let me just also mention that there is also a famous combination. This appears a lot in trigonometry. 1 over cosine is called secant, and 1 over sine is called cosecant. Yes? CSC means cosecant. You read it cosecant, and this is secant, and this is cotangent. So if you see some other books, might be you also see these. I think in the PDF file of this American teacher, you will see these quite a lot, but that's nothing. So whenever you see this symbol, it means 1 over cosine. Whenever you see this symbol, it means 1 over sine. And whenever you see this symbol, you see it is cosine over sine. Yes? Okay, for example, let me ask you to calculate the exact value, to determine the exact value sine of 120 degrees. Here you have two options. Either you can solve it using supplementary angle formulas, or you can use complementary angle formulas. Yes? Let us solve it in two different ways. Okay? First one, supplementary. So instead of sine of 120, what can I write? What is the supplement to 120? The supplement of 120 is 60. And we learned here that sine of supplementary angles are exactly the same. So there is no difference between sine of 120 and sine of 60. But 60 is one of those famous angles that you can have access to the value of it, and if you look it up in the table, it is square root of 3 over 2. So this is answering this question using supplementary angle theorem. But you can also view this as, so it is not a good way to do it in complementary, because what is the complement? Yeah, that you can do that, yes. So number 2. So what is the complement of 120? What is the complement? Minus 30. And we just learned that if you want to use the complementary angle perspective, you would say that sine of 120 is equal to the cosine of its complement, which is minus 30. But we just learned that cosine of minus an angle is equal to the cosine of the angle. So this becomes exactly equal to cosine of 30 degrees. And if you go and look it up, cosine of 30 degrees is also square root of 3 over 2. So in the intermediate steps are different, but the final answer, which matters, is actually the same. Are the same. So this becomes complementary trick, yes? So if you want, you can answer this question using supplementary angle theorem or complementary angle theorem. The one thing that is also good to remind you is this idea. By the way, all the formulas that I have written in degrees, you can repeat them in radians. Okay, for example, this one, no, that one, no, this one. So instead of sine of 180 degrees minus theta, you might see sine of pi minus theta. That will be the same thing. But in that case, here, theta should be expressed in degrees, because otherwise I cannot subtract, I do the subtraction. If you write pi, then theta should also be measured in radians, yes? But the formulas are the same. And then hopefully you can answer these, yes? Do you remember, if I ask you what is the sine of, I don't know, an integer multiple of 360 degrees plus theta? So n is an integer. So let me emphasize for all these parts. N is an integer. Okay? And I multiply 360 degrees by an integer, and I add it to my angle. What can I write in front of this? How this relates itself to the sine of the theta? How? Did you use all your phosphorus in your brain for physics exam? So what is this? N times 360 degrees, you're adding it to theta. So you're adding complete revolution, rotations about the origin. So you will come back to the same point. So this means that sines are the same, cosines are the same, tangents are the same. So that's also good to know. So this becomes, if you add a multiple, positive or negative, integer multiple of 360 degrees to an angle, you are not changing sine, you are not changing cosine. Yes? Of course, you are not changing tangent, yes? This is clear, because when I do this, I will return back to the same point, even though my angle might be different, which is, but the final point is the same. So as far as I am concerned, I'm concerned about the x and y coordinates. If the points are the same, the coordinates are the same, so sines and cosines and tangents are all the same. Yes? But for tangent, if you remember, we discussed that before, we can say a little bit better. Yes? For tangent, of course, this is true, not wrong, but we can say something more powerful. We can say that you don't need to return back to the same point in order to have the tangents the same. You can end up at the opposite point. So it means that instead of going one full round, you can go half a circle each time. So this is why for tangent, it is better to remember that this is a crucial, by the way, that this is the idea. So for tangent, of course, not only this is working, but if you write 180, that's also working. Yes, but for sine and cosine, you have to write 360 degrees. It will not work if you just go half around. Yes. Okay, so to finish this, I would say that let me solve an exercise. What type of exercises you might expect for this lesson? So let me write it down here and then try to solve it together. So without calculator, show that we want to prove this. We want to prove that sine 200 degrees plus 2 times sine 160 degrees minus cosine of 70 degrees plus 3 sine 340 degrees. We can skip this, and then finally minus 4 cosine 110 is equal to sine of 20 degrees. So we want to prove that we don't know these numbers. They are not famous numbers, by the way. But we want to show that what number is this left-hand side. This is exactly sine of 20 degrees. So we can simplify the whole expression on the left without even knowing what are the values of these. We want to confirm that whatever the left-hand side is, it can be summarized just to sine of 20 degrees. Okay? Okay, I have to change this. So you see that what we want to show is to show that this left-hand side is equal to sine of 20. So we should have a target angle here, yes? So none of these angles are something that we need. Okay. And 200, 160, 70, 340, 110. Instead of all these angles, what I need 20 degrees. So it motivates me, if possible, try to write everything in terms of 20 degrees. Yeah, so that is the strategy that I choose, yes? Because we should have a strategy, we just don't do the random calculations, yes? So this, and if you understand this, then it becomes easy. So for example, if I ask you how 220 are related, you say that 220 are not supplementary, not complementary, but 200 with negative 20, they are supplementary. Yes? So this means that I can connect 200 to minus 20. And because of these formulas, it is easy to connect it to 20 itself. So we just start doing it, okay? So let me change my color. So here, sine of 200 degrees. Okay, how do you write it? Can you understand what should I write? You realize minus 20 is the supplement here. What is the rule for supplementary angles? It is on the board. Sines are exactly equal. So if I write sine of minus 20, do you understand it or not? Yes? Because minus 20 and 200 are supplementary, and this is on the board. We discovered it once. So the sign of supplementary angles are exactly equal. But because of this minus sign, and I need another rule that is still on the board, so I pull this minus sign out. Yes? So this becomes minus sine of 20. Okay, so far so good. Now I need another one. But that is also probably simple for you now. So 160 degrees, what is its supplement or complement? You need to think in that way, yes? 20. And then exactly the same formula. So there is no difference between sine of 160 and sine of 20. That's it. We go to the next one. Cosine of 70. How 70 is related to 20? It is its complement, yes? But the rule is on the board. Cosine of an angle is not equal to the cosine of its complement. It is equal to the sine of its complement. Yes? So this becomes equal to what? Sine of 20 again. Okay, what about this one? Sine of 340. How it is related to 20? Yeah, you visualize that. That's completely okay, by the way. If you think that your memory is not that good enough, you can always visualize that, yes? But you are right. I will write it like this. Instead of this, do you agree that I can write 360 degrees plus minus 20, yes? 360 degrees plus minus 20 is exactly 340. But why this is useful? Because this is one full round I am adding to an angle. I will return to the same point. So I can just drop that. This becomes sine of minus 20. Okay? And then what is the answer? Minus sign goes out, so it becomes minus sine of 20 degrees. But as Kajal said, you can just visualize it. All of them, if you forget, you visualize it, but you need to be able to spend a little bit of time to convince yourself about these kinds of arguments. Okay, anyway, sine of 340 is minus sine of 20. And finally, how this one and that one are related. Cosine of 110. Do you agree that if I write it as sine of minus 20? Yes? Because 120 and minus 20 are complementary. So cosine of one of them is equal to sine of the other one. But we just learned that this minus sign can go out. So everything is now settled down, so we can actually continue to this problem. So I want to prove an identity. I want to prove an equality. So I'll start from the left-hand side and try to reach to the right-hand side. But instead of sine of 200 degrees, I can put minus sine of 20. So you see, instead of this first term, I can put this. So it becomes minus sine 20 degrees. And then instead of sine of 160, I can write sine of 20, but there is a factor of 2 involved, so it becomes 2 times sine 20. Cosine of 70 degrees is sine of 20, but there is a minus sign there. And then sine of 340 is minus sine of 20. There is a factor of 3 and a negative sign there. Multiply them together, it becomes minus 3. And finally, cosine of 110 is minus sine of 20. There is a factor of minus 4. So this becomes 4 sine of 20. If we haven't done any mistakes, they should cancel out. Yes, this one and that one are cancelled out. Yes. But I have 4 of them minus 3 of them. So it becomes 1 of them. Yes. And that's equal to the right hand side. Okay, so now I changed the topic to a new lesson. Any questions here? Okay, so this is a very important one. This is completely new. Of course, if you have already studied on your own, that's enough. But this is not something you had seen it before in Math 3C. So mainly, nothing is that new so far. But this one is completely a new lesson, okay? Okay, because if I want to start the next lesson, I realize that it is quite lengthy. And it is not good if I break it into 2 parts. So let us try to practice a little bit here. I can also solve some problems in the book so that we can have some exercises. But let me solve a more interesting problem here. That's a little bit hard problem. I would consider it a hard problem, but I don't think this is something that you don't understand. The question is this. Someone has calculated tangent of 75 degrees for you, and they are claiming that this answer is exactly 2 plus square root of 3. Based on what I will teach you next time, the new lesson that I skipped, you will be able to find this exactly yourself. But for the time being, take this for granted, that someone has already calculated tangent of 75 degrees, which is not a famous angle, and they have come up with this answer. Based on this piece of information, without using any calculators, you are supposed to find the exact value of the following fraction. So we want to calculate 3 sine of 375 degrees plus 2 sine 105 degrees divided by cosine of 165 degrees and then minus cosine of 255 degrees. So you should be ready to do a combination of these kinds of work and then visualizing things in the unit circle. So the question is that if I give you this number, take it for granted, my question is that what is the exact value of this fraction then? This is related to our lesson that we just talked about. Okay, so what is your first impression about the problem? Because you should have a strategy, not random calculations. The worst thing you can do in mathematics is to start doing random calculations. So yes? Okay, but yes, this is one strategy, but is it a good one? So how do you want to achieve that? A better strategy, you shouldn't be so detailed about your strategy. When I say a strategy, I mean grand picture. Because the piece of information given to you is related to 75 degrees somehow. Yes? So but the numbers that are involved here are apparently not related. They are not, clearly not 75 degrees, but they might be somehow related to 75 degrees according to what we just learned. So the grand picture or grand strategy would be to write everything, if possible, in terms of 75 degrees. And then let us see what happens next. Okay, if you have this strategy in mind, might be it is not that hard to visualize it. Okay. For example, this is probably the simplest scenario. Let us start with that one. So sine of, let me change my color. So sine of 105, you immediately know what is that, yes? Or hopefully you know, yes? What should I write in front of this? So you have this strategy. You want somehow to connect this angle to 75 degrees. And then you have this lesson in front of you. So what should I write in front of it? Yes? Why? They are supplementary. Yes? If I ask you what is the supplement of 105, you would say 75. And then we learn that the signs are the same. So this is exactly equal to sine of 75 degrees. That's very good. What is your opinion about, let me write all of them, sine of 375 degrees. I don't know, can you connect it to 75 degrees in a way? Yes? Okay, so yeah, that's correct. But then how do you sum it up? So what should I write? No, the first thing that I do, I go for 15, not 75 directly, yes? Because what I write sine 360 degrees plus 15. But what can I do with the 360 degrees here? I can just take it out, yes? Because that's one full round. It becomes sine of 15. But my goal was not to connect it to 15. My goal was to connect it to 75. Then it is not hard to see 15 and 75 are complementary. So then it means that sine of 15 can be written in terms of 75. But the price that I have to pay is to change sine to cosine. Yes? At least I succeeded to write this in terms of 75 degrees. Yes? So that's good. We go to 165. Now I think now you realize what is the trick. You can answer this question in two different ways. Which one I'd prefer, I don't know, because you can use complement angle here, or you can use supplement angle but in two steps. So what is the complement of this angle? An angle so that when added to it, it becomes 90. It's minus 75. Okay? So, but cosine of an angle is not equal to the cosine of its complement. It is equal to the sine of its complement. Yes? So cosine of an angle is equal to the sine of its complement. But what was the rule for sine and negative sine? Negative sine goes out. Yes? So this becomes a negative sine of 75 degrees. So far, so good. So there is only one thing left, and that is 255. And that's probably also easy. Yes, isn't it? So cosine of 255, how do you connect it to 75 degrees? What is the supplement of 255? Minus 75. Yes? So it's minus 75, supplement. Do you remember? I actually erased that. Do you remember how cosines of supplement angles are connected? So if you don't know them by heart, you have to visualize it all the time. But that's also good. So how cosine of supplementary angles are connected? Can you visualize supplementary angle? One of them was here, the other one was opposite, horizontal opposite. So the x coordinates are negative of each other. Yes? So this becomes a negative of cosine of its supplement, which is minus 75 degrees. But cosine negative, this will actually absorb the negative sign, but there is a negative sign outside, it will remain. This one is gone because of cosine. So this becomes minus cosine of 75 degrees. Yes? No, I told you for cosine, minus sign does not go out. It is completely cancelled. Okay, so now what is the question mark? So the question mark is equal to. So what can I write now? 3, instead of sine, let me just show you. Instead of sine 375 degrees, I can write sine of, I can write cosine of 75 degrees. So it becomes 3 cosine 75 degrees. Okay? So, but now instead of sine of 105, I can write sine of 75 degrees. There is also a factor of 2. So it becomes 2 sine 75 degrees. And then you divide. Divide by what? Cosine of 165 degrees is negative sine of 75 degrees. Yes? And then minus cosine of 255. Cosine 255 itself is negative cosine 75. There is also a negative sign there, so it becomes plus cosine 75 degrees. So that's a very good progress. Why? Because at least I wrote everything in terms of 75 degrees, which is the information provided for me in the problem. But there is one problem here. The information is related to tangent, but this fraction is related to sine and cosine. How can I solve this problem? Because I want to find the exact value. If you stop here, that is good, but that's not complete yet. So how should I do that? Yes? Yes? Yes, you can somehow use it if you want to, but I hope that you are not tempting to divide these two separately and separately, because that's an addition there, yes? But sometimes you get desperate and you finally do that, but this is not working in mathematics, yes? If something is wrong, it's wrong forever. Yes? No, but then that the problem will be something else. Then how should I find that one? Yes, because the only piece of information I have is 75 degrees. Here I expect you to give me a very straight answer right away, even though it's not the most efficient answer. Yes, because we just learned, and I put a star there, that in principle, if tangent of an angle is given, you should be able to find sine and cosine out of it. And I told you that that problem is not hard, but it appears a lot in trigonometry, and thank you for listening, okay? So this is what I'm saying. If I give you tangent of 75 in exam, I will not probably give it in exam, might be that's a harder question, but I might give you this question that, okay, tangent of 75 is 2 plus square root of 3, find sine of 75. I give you tangent of 75, and I ask you to find sine of 75. This is exactly at the right level of your book. So how do you find that? We had two problems. I marked them with a star. I told you that, remember, these are prototype examples. These are the examples that you should have in mind. If I give you sine, you should be able to find cosine and tangent. If I give you cosine, you should be able to find sine and tangent. If I give you tangent, you should be able to find sine and cosine. Okay? So if you have forgotten, review that video on that example. Okay, but in this case, it is not efficient at all if I want to do that. Okay? In principle, this is a good question for you at home. Go and solve this problem. Tangent 75 is this. Find sine of 75. This is one question at the level of the book. By the way, it's not A level, probably it's a C level question. Okay? But here, if you are smart enough, you can find a much faster way. Yes? Trigonometric identities, yes. Trigonometric identities are useful if you want to calculate sine and cosine separately from tangent of 75. Yes. Pardon? No, you cannot raise it to power 2. Yes, unless you also raise question mark to power 2. And then remember what you gain at the end, take a square root. Yes? Because if I have an expression, if I have this one, this is a wrong attitude. You just square it. Because I am asking you to solve a square root of a. You square it and get rid of a square root sign and say that this is your answer. Unless you square it, do whatever you want to do, but remember to take the square root sign again at the very end. You cannot change the problem. Yes? This is different from this situation. Here I can get rid of a square sign because I am raising both sides to power 2, and I'm claiming that if this is equal, that's also equal. This is different from having one single expression and just raise it to power 2. Yes? Okay, so the trick is divide everything here by cosine of 75. Okay? Because here you see that I am not changing the problem. I am doing something to rescale my fraction. This is a fraction. I am allowed to multiply the numerator and the denominator by any number that I like. I can also divide the numerator by any and the denominator by any number that I like without affecting the fraction itself. So what I do, I decide to divide everything by cosine of 75 degrees. And then it is clear why. Why it is good? Because if I divide this by cosine of 75 degrees, there are two terms to divide. If I divide this term by cosine of 75, it becomes simply 3. Yes? If I divide this by cosine 75, it becomes what? Tangent. Yes? If I divide this by cosine 75, it becomes minus tangent. If you don't mind, let me write it here. And if I divide this by cosine 75, it just simply becomes 1. Yes? So you need to write down in your notebook, so might be you forget in the future. Okay? So how did I come from here to there? I rescaled my fraction. Okay? I divided the numerator and the denominator by cosine of 75. What was my motivation by dividing by cosine of 75? Okay, because you immediately see that what is left is exactly what I have. So I can answer my question regarding that piece of information. So what you need to do, you need to write 3 plus 2, and instead of tangent of 75, you write 2 plus square root of 3, and then divided by 1 minus 2 plus square root of 3. And let us simplify this a little bit. 2 times 2, 4, plus 3, 7. 2 times that is 2 square root of 3. And in the denominator, I will have 1 minus 2 minus a square root of 3. So it becomes minus 1 minus a square root of 3. If you want, you can factor a minus sign out. It becomes 1 plus a square root of 3, 7 plus 2 square root of 3. Yes? So I would say that up to here, I wouldn't expect this is hard for you. Might be this is one trick. By the way, when you want to be a good problem solver, you have to have these examples in your mind. Okay, take lessons if you want to be very strong problem solver. Otherwise, you don't need to worry about. So the reason that I was able to solve this, because I had some experience how to do these things. Yes? But what I expect you to do, this is what I'm saying. In principle, after this stage, if you have learned the lesson in a good way, you should be able to solve it. But not very efficiently as I did here. But in principle, everyone should be able to find sine and cosine of 75 out of this information. And when you have them, you can put them here. It becomes much longer, I agree, but this is doable. Yes? Any questions? Okay. There is a little bit of time left. Let me just continue this problem. I want to teach you some arithmetic as well. So if you want to simplify this, it is not needed, of course, but I think that's also necessary to know. If you want to simplify fractions with third sign in the denominator, usually it is better to get rid of that third sign. Third sign is this sign. This sign is called the third. Yes? So you want to get rid of that third sign. Can you give me a way to get rid of that third sign? In the denominator. I don't have any problems with having third signs in the numerator. But I want to get rid of them from the denominator. Can you just propose me something to do that? So what can I do? Of course, I don't want to change the problem. I want to keep the fraction the same and rewrite it in a way which is equal to this fraction on the one hand. On the other hand, I do not have third sign in the denominator. The trick here is to use the conjugate rule and rescale the whole fraction by the conjugate of the denominator. Yes? So I multiply and divide by the same number. What is that number? It's the conjugate of that. Why this is helpful? Because this minus sign is this minus sign. When I multiply the denominators, this reveal a conjugate pattern. The conjugate pattern tells me that this is the first one to power 2 minus the second one to power 2. And that power of 2 helps me to get rid of the third sign. But of course, the price that I have to pay is to multiply this. Let us just be patient and multiply that. So 7 times 1 is 7. 7 times square root of 3 is minus 7 square root of 3. And then 2 square root of 3 times 1. And finally, 2 square root of 3 minus a square root of 3 being multiplied. The answer becomes negative what? 2 square root of 3 times square root of 3. What's the answer? 6, yes? Because the square root of 3 times the square root of 3 is 3, and there is a 2, so it becomes 6. Yes? So what happens here? This 7 and that 6 becomes 1. And then minus 7 square root of 3 plus 2 square root of 3 is how much? Is minus 5 square root of 3 divided by 1 minus 3. So this becomes minus 2, and I write it here, so it becomes minus 5 square root of 3 divided by 2. Okay, but that's of course not necessary. But sometimes you might find this answer, but when you check the faucet, because usually if there is a third sign in the denominator, mathematicians try to get rid of that. And then when you find this, you might think that you have made a mistake, but this is the way that you can simplify it to this one. So that's also a trick, good to learn. Okay, we stop here. This is just half a page in the book, so I will update the Google Classroom. Okay, you can work. But the next lesson is actually very important. Any questions? Okay, thank you very much.